Alright, thank you for tuning into another physics lesson with Mr. M. In today's lesson, I'm going to be talking about coefficients of friction. This topic falls within the dynamics or forces unit, and it goes to specify different types of friction forces. So as we know, a friction force is just a force that opposes our motion. And as you see here, we have two different types of frictions. We have what's known as static friction, and static, that word static used in physics just means that the object is not moving. So when we talk about static friction, it's the frictional force that's basically keeping that object stay put. So our static friction, we say it's the force that gets an object to move from rest. And symbolically, this symbol that we use for the coefficient of friction is the Greek letter mu, and the static friction gets a subscript s. On the other hand, we have something known as kinetic friction, kinetic meaning the object is moving, and so this is the frictional force that basically the force that keeps an object moving at a constant speed, and this gets the symbol mu sub k for the coefficient of kinetic friction. Now that specifies the two types of friction. However, we do have a friction equation, and the equation looks like this. Our equation is our friction force is equal to our coefficient of friction times the normal force. Okay, so we use this in conjunction with our free body diagrams to help us solve problems that include static friction or kinetic friction. The important part in this equation, and by the way, your mu value will always be a decimal, and that decimal basically is trying to convey how much friction. So if you have a large decimal, then you're going to have a greater amount of friction. If you have a smaller decimal, you're going to have a smaller amount of friction force. Okay? And so the other main part is we need to know what our normal force is. Okay? So solving for Fn is critical for these problems. And so you may not always get they might not just tell you the normal force. You may have to figure out what the normal force is. And then once you know the normal force, and if you're given the coefficient of friction, you just multiply them, and then boom, you have your frictional force. Okay, so let's take a look at an example of this. We're just going to ask what force will get the block to move. So what force will get the block to move? So first thing that we need to do is draw our free body diagram, and along with drawing those force vectors, include the equations. So we have our weight force going downwards, we have our normal force pushing up on it, and we want to know what is the amount of force that will actually get this block to move. Let's say we want to move it to the right. Well, if we move it to the right, we know we have a frictional force. And so the idea here is, if we can solve for this frictional force, we will know how much force is required to go to the right, because they're going to be essentially equal and opposite. And so if we solve for the frictional force, we'll know how much force to use towards the right to actually get this object to move. Okay? And so going back to our equation, the frictional force is equal to mu times the normal force. We want to know how can we solve for the frictional force? Well, let's go back to our free body diagram here. We know that the weight and the normal force are equal and opposite to one another. So we can say that the normal force is also equal to the mass times gravity. So we know that Fn is equal to mg. What we're going to do is we're going to take this and by substitution plug it in to Fn. So our frictional force is going to end up equaling our coefficient of friction times mass times gravity. Now if we knew what our mass was and we knew what our coefficient of friction would be, we would just multiply that by gravity, boom, we'll get our force of friction, and then we will also know how much force will get the block to move. So that would be our equation to solve our problem. Okay, let's do one more example problem. Our typical block on an incline. And we're going to ask, let's set some values here first of all. Let's say our mass is 2 kilograms. Let's say that our coefficient of static friction is 0.3. And let's also say that our angle is 45 degrees. Okay, we want to know, based on this information, will this block accelerate down the incline? Well, to help us with that, let's go ahead and draw our free body diagram. Weight straight down. We have our normal force perpendicular to our surface. Whenever we have an angled vector, we have to break that vector into its x and y components. So our angle theta is always between our vector and the y-axis. So we're going to break this gravity into its x and y components, because this vector here is adjacent to this angle. We get mg cosine theta. This one then would be mg sine theta. And we also know that we have some frictional force. And so, because our question is, will the block accelerate down the incline? Basically, we need to know, is mg sine theta, is this vector going to be greater than the frictional force? And if it is, then the block will accelerate. If it's not, the block will stay still. So how are we going to solve for that? So, as we mentioned, will mg sine theta be greater than the frictional force? Well, let's go back to our equation. Frictional force is mu Fn. We said it's so critical. What is the normal force? Well, in terms of our free body diagram here, our normal force is going to be equal and opposite to this downward vector. So our normal force is really equal to mg cosine theta. So Fn equals mg cosine theta. We're now going to take this and we're going to substitute it into our equation. So our frictional force is equal to mu times mg cosine theta. We know what mu is, we know what mass is, we know what the gravity is, we know what our angle is. We can solve for this. So let's go ahead and do that. Our frictional force is going to be 0.3 times our 2 kilograms times an acceleration of gravity, 10 meters per second squared, that's a rounded up value, times the cosine of 45 degrees. Our friction force comes out to be 4.2 newtons. We need to compare this to what mg sine theta is. And if mg sine theta comes out to be greater than 4.2, then yes, our block will accelerate. So let's solve for mg sine theta. So we have 2 kilograms times gravity times the sine of 45. We end up with a value of 14.1 newtons. Okay. So we have 14.4 newtons downwards. We have a frictional force of 4.2. That's going to give us, and we can write a net force equation out of this. We know that this is greater than that, so yes, our block will accelerate. Our net equation would be 14.1 minus 4.2. That gives us a 9.9 Newton net force. We could then divide that by the mass of 2 kilograms to find the acceleration. All right. So in review, we have 2 different types of frictional forces. The frictional force is our coefficient of friction times the normal force. Figure out what your normal force is. You can then multiply it by the mu, the coefficient of friction, to get your frictional force. Apply that to a net force equation to solve your problem. Thank you for tuning in to another physics lesson with Mr. M.